Okay, thank you. So I'm Tomohiko, not Tomoko. So, yeah. I like to explain introduction of our research. Yeah, uh, this year, we are having the very hottest summer in our history. Statistically, global mean temperature increased by 1.1 degrees Celsius, and during these 130 years, and and also in cities, we need to care about also urban heat islands. The annual average temperature in Tokyo has increased by 30 degrees Celsius over the past 100 years. And of course, high temperature affects our human health, and this representativeness of human health impact in Japan is heat stroke. This is the number one emergency transport due to heat stroke in Japan. And as you can see from this figure, 50,000 to 100,000 people are transported due to heat stroke every year. And some of them died. This is the death from heat stroke in Japan. More than recently, more than 1,000 people died every year. And in Japan, this is one order of magnitude more than disaster death. So, of course, we need to install historical countermeasures. But also, we need to consider aging. This is aging situation in Japan. The elderly people is increasing globally in the world, and Japan is the most aging country, maybe as you know. And currently, 30% of its population is aged people, but in 2050, about 40% of the population is aged person. And aging is not just changing in age. Aging brings about brain and body changes, and sometimes leading to dementia and also physical frailty as a pathological state. Age-related health problems are seriously addressed in developed countries. And also aging is considered one of the risk factors of heat stroke. To design reasonable adaptation to heat stroke, we need to identify what we need. Yeah, education of vulnerable people is essential. Also, what exactly makes aging vulnerable people factor we need to consider. Who is vulnerable people? Several research have detected risk factors: education, income, living alone, going out, requiring nursing care, dementia, social activity, use of air conditioning. But these two items are not detected by social surveys. These two literature items are not social survey, but outpatient clinical experience. And also, this kind of studies are what have been conducted in uh, other countries, not Japan. But Japan has very serious its problem, and also the most aging country. We need to identify Japanese situation. Our objective is identifying socioeconomic factors associated with heat stroke, focusing on the elderly in Tokyo, Japan. I'll explain a methodology of our survey. First, our case study is Kashiwa City. Kashiwa City is a suburb of Tokyo. And we prepared two subjects. One is participants of crowd activity in Kashiwa City, and also another is all 2,450 households in public housing complex in Kashiwa City. And we conducted self-adjudicated questionnaire survey. And in the questionnaire, we asked two items. One is socioeconomic factors, and another is historical experience in the past 5 years. And after the survey, we conducted statistical analysis. We adopted univariate logistic regression analysis. I from here, from now, explain our result. And this is the number of respondents. So we distribute the questionnaire to 2,067 people. And we got this result. And finally, valid responses is 747. Then this is the result of socioeconomic factors. So 40% is male and 60% female, and 40% is living alone. And age of the respondents. Mean of age is 73, and majority are here. And this is educational background. So half of them is high school. And this is personal annual income. So 25% is less than 1 million Japanese yen. And requiring nursing care. So 68 respondents required nursing care. And 25% is going out in a week, less than 4 times. And 60% didn't participate in social activities. And 12 respondents, in 12 respondents, dementia was suspected. And this is ownership of air conditioners and use of air conditioners. And this is the result of heat stroke experience of respondents. So among 700 respondents, so 45 people experienced heat stroke. So emergent transport or medical examination. And this ratio is very high. So this is the situation of Tokyo Metropolitan, and only 0.1% experience heat stroke. So this number is really high. So we can say the respondents were an extremely vulnerable group compared to the general population. And we conducted the univariate logistic regression analysis. So gender, age, household size, education, and annual personal income. And we can find living alone can be identified as one of these factors. So so this is odds ratio. So odds ratio is twice. And also we detected requiring nursing care and suspected dementia and ownership. These two factors are also risk factors. And suspected dementia is really strong. So this odds ratio is 8 times. And on the other hand, ownership of air conditioners can be protective factor, and the odds ratio is 0.3. So compared to heat wave study in Chicago, so it was considered that elderly who lived alone was a risk factor. So we can consider, room temperature might not be set appropriately, and if they present mild symptoms such as dehydration and high body temperature, it might be overlooked. And use of air conditioners was strongly protective factor. In these two past studies, however, use of air conditioners was not identified as a protective factor in this survey. Ownership, on the other hand, ownership of air conditioners was a strong protective factor in this survey. Maybe it's difficult to question the appropriate use of air conditioners because of and also aging might be a risk factor, while requiring nursing care and suspected dementia are strong risk factors. So we conclude here. So for socioeconomic factors, living alone, requiring nursing care, and suspected dementia were identified as a risk factor. And ownership of air conditioner was identified as a protective factor for heat stroke. And we can, based on these results, we can suggest regarding adaptations. Aging cannot be avoided, but heat stroke in the elderly can be reduced with things. So in order to prevent isolation and heat stroke among the elderly, there's a need to build a conference elderly support networks to detect change in the situation of the elderly. And the social activity to prevent caregiving and dementia should have an indirect effect on heat stroke prevention. And we need to design integral heat stroke measures that vulnerable people can actually install. So thank you for your kind attention. Thank you.
There are some questions in the podium.
So thank you very much for your presentation. So in the study, you found that owning an air conditioner is a protective factor against heat stroke. So I'm just wondering if owning an air conditioner would it be an indicator that this person will be more well off than others, such that he or she owns an air conditioner because it's some money to afford that. So it's not the ownership of that AC itself, but it is the socioeconomic status that of that person affecting that the offering the protective effect. So what do you think about this point?
Thank you for your question. So this time, we conducted univariate distribution analysis. So here we consider only ownership air conditioners, but as you said, economic situation must affect this factor. So if possible, we should also conduct multivariate logistic analysis, including the ownership of air conditioners and their economic situation. But our sample number is small, so maybe it doesn't work. Thank you very much.
Thank you very much for the presentation. I would like to ask about the use of air conditioner. So, what was the question to identify this factor? And also, I'm also familiar with logistic regression. So, could you explain how to interpret the operation? What number means what?
Okay, thank you for your question. So first question is
What was the question to identify the use of air conditioner?
Did you use air conditioners, your air conditioners appropriately? So while it's hot, but maybe some people didn't recognize it was hot. So actually, we got this kind of result. And another is logistic regression analysis is explained value parameter is binary value, so 0 or 1, and and odds ratio. I mean, for example, suspected dementia people is 8 times more likely to suffer heat stroke compared to normal people. That makes sense? Oh, thank you very much.
Thank you so much.
Thank you.